Okay, given that y equals to 2 plus 3x square minus x cube. Okay, 2 plus 3x square minus x cube. So find the first derivative, which is 6x minus 3x square. Okay, to find the stationary point, your first step, first find the first derivative, second make the first derivative equals 0 to find the stationary point. Okay, so x, 6 minus 3x, so you can take out 3x, just 2 minus x equals 0. So from here x equals 0 and x equals to 2. Okay, find the stationary point. Okay, or the coordinate. So sub x equals 0 into the function, so y equals to 2 plus 3 0 square minus 0 cube, which will give me 2, and when x equals to 2, y equals to 2 plus 3 to the power of 2 square minus 2 cube, which is 4, 12 minus 8 plus 2, 4 plus 2, 6. So therefore two coordinate stationary points that we got are 0, 2 and 2, 6. Two stationary point, but we have to determine the nature, whether it's a maximum point or minimum point. Now let's sketch the graph. Okay, I'm going to choose few values. Okay, let's say I already have x equals 0, so I'll choose a value before 0, which is -1, and then x equals to 2, so I'm going to choose few values between 0 to 2 and one value up to 2. Okay, let's find out what is the gradient for each point. So dy dx equals to 6x minus 3x squared. So 6 times by -1 minus 3 -1 square, which gives me, that's -6, and that's positive times negative, so it's a negative gradient. Okay, if it's a negative gradient, the graph will be going downward. It's a decreasing graph. Okay, at least at that interval. Okay, next dy dx, and this time I'm going to sub 0. So 6 0 square minus 3 times by 0, and it is a 0, so that shows it is a stationary point. Okay, or stationary value over there, because it's a flat graph, so gradient equals to 0. Next, you can take dy dx, this time x equals to 1. 6 times by 1 minus 3, 1 square. So this will give me 6 minus 3, which is positive value again. It's a positive value, so if it's a positive value, it's an increasing graph. Okay, so it's going up. Next, dy dx equals to 6. This time I'm going to choose 2. So 2 square, so it's 2 minus 3 times by 2 square, and the answer is 12 minus 12, which is 0. Okay, value over here is 0. So if it's 0 like here, so it is another stationary point. Okay, the graph gradient is 0, it's just a flat line. And finally, dy dx, x equals to 3. So 6 times by 3 minus 3, 3 square, which is 18 minus, that's 9 times 3, 27, and it is a negative line. So if it's a negative line, it is going downwards. It is a decreasing point, I mean graph. Okay, so at that point, so from here we can see the pattern. It is a graph that down, up, and then down. So it's concave downward and then it goes back to concave upward. From here we can determine the maximum or minimum. So we know this point here is the lowest point of the graph, so it is a minimum point. So you can find out by doing d2y to check, or from our working over here we can know for sure that it is a minimum point. But otherwise you can do double differentiation. When you do double differentiation, you get 6 minus 6x. When x equals to 0, you get a positive value. Okay, so a positive value, which is 6, and this proved that it is a minimum point. So the point over here is 0, 2. Okay, and then the point over here, which is the maximum point, d2y over dx2, 6 minus 6x, again 6 minus 6 times by 2, which is 12, and it is a negative point. So if it's a negative, that proves that it is a maximum value. So this is a maximum value when x equals to 2, y equals to 6. Okay, so basically that's how you do the nature. So remember, you can likewise you can do um, a double differentiation, or okay, you can do the graphing method. So for graphing, you have to pick few x values, and from there you can see the pattern of the graph. Okay, whether it's going upward and downward, concave up and down, or concave down to up. Okay, so there you go.